We are solving question number 12 of this work power energy for M1. A particle of mass 0.8 kg slides down the rough inclined plane on the greater slope of AB. The distance AB is 8 meters. The particle starts at A with a speed of 3 meters per second and moves with a constant acceleration of 2.5 meters per second square. Part 1. Find the speed of the particle at the instant at it reaches B. Part 2. Given that the work done against the frictional force acting on the particle in traveling from A to B is 7 joules, find the angle of inclination of the plane. Then, when the particle is at the point X, its speed is the same as the average speed of the motion from A to B. Find the work done by the frictional force for the particle in moving from A to X. Since we are going to calculate the velocity of B and it is moving against the frictional force, but we know that we will use the equation of motions. So V square minus U square is equal to 2AS. So velocity at B is V there and velocity at A is U there. So V square as it is equal to U square plus 2AS, which is equal to U is there 9 plus 2 into A there is 2.5 and S there is 8. So this thing is equal to 49. So velocity at B is equal to 49 square root and that thing is equal to 7 meters per second is the answer for the first part, that due to this velocity it is going to move at the point B there. For the second part, given that the work done against the frictional force as the particle moves from A to B is 7 joules. So work done against the frictional force is 7 joules. Find the angle of inclination of that plane. So we are going to calculate this angle theta there for that calculation. Now we know one thing, that work done, because it is moving downward, so work done by the driving force minus work done by the frictional force is equal to change in kinetic energy of the system minus mgh, the total height gained there. Since this particle is the driving force of that engine and there is no extra force acting on that particle, so the driving force of that will become equal to 0 minus the frictional force is there, which is by the work done against the frictional force is 7. That thing is equal to half. Mass is there equal to 0.8 into V square. Velocity at B is 7 minus velocity at A there is 3 minus M there is 0.8 into G is there 10 into height as it is. But we know from this calculation that height, if this is the height, then height over S is equal to 8, or height over S is equal to sine theta. So H is equal to S sine theta, where S is there equal to 8 into sine theta. So it will become 8 sine theta. And then from this calculation, we can calculate the theta there, which is being calculated as it is. Sine theta is 23 over 64. So taking sine inverse of 23 over 64, and that thing is equal to 21.06, or you can write it as 0.1 degree. So this is the second part of that you are going to find out the angle of inclination of that point there. Now, the third part of that, no, the last part of this. When the particle is at a point x, its speed is the same as the average speed of the motion from A to B. Find the work done by the frictional force of the particle motion from A to x. Since in this last part, it is started from A, where u is equal to 3 meters per second. It is going to move at the point x, and this is the new height which is being obtained in this part, and it is having an angle of 21.1 degrees because it is being calculated in the last part of this calculation there. So we are first going to calculate speed at x, and the speed at x, they say that it is the average of A and B, but A speed is at point is 3 meters per second and B speed is 7 meters per second. So average speed of x there is equal to 3 plus 7 over 2, and that thing is equal to 5 meters per second. And now you will calculate the distance from A to x. We know that v square minus u square is equal to 2as. So v square is the speed of x, and that thing is being calculated equal to 5 equal to u square. It was already there, 3 square plus 2. A acceleration is already given there, 2.5, into the due distance, that is S1, we are going to calculate. So S1 is basically equal to 25 minus 9 over 2 into 2.5, and S1 is basically equal to 3.2 meters. So this is 3.2 meters. And now we have to calculate the work done by the frictional force when it is going to reach at the point x. We know that work done by driving force minus work done by frictional force is equal to change in kinetic energy of the system, because it is coming downward. So potential energy will be lost. So that thing is equal to mgh. But work done by driving force is equal to 0, minus work done by frictional force as it is, half into mass of that particle is 0.8 into v square, that is the speed at x, and that is going to be calculated equal to 5 minus speed of particle at A is 3 square minus m, that is 0.8, g is there 10, and the height h1 is basically equal to h1 over 3.2 is equal to sine of 21.1, or h1 is equal to 3.2 into sine of 21.1. So we can write it here into 3.2 into sine of 21.1. So this calculation will be equal to minus work done by frictional force is equal to 0.4 into 25 minus 9 is 16, minus 0.8 into 10 is 8, into 3.2 into sine of 21.1, or frictional force work done by that particle is being calculated equal to 2.8 joules. So this is the work done due to the frictional force of that particle in this motion when it is at x, where at x the total speed is the average of A and B there.